continue our work on proportions, and I'm going to extend it today into percents. Percents are a particularly specific type of ratio. It's a ratio that compares a number to 100, and we're going to utilize proportions to solve percent problems. But before we do, let's talk about where in everyday life we encounter percents. So make a list, and we'll share them in a few moments. In this lesson, we have a couple of goals. We're going to solve percent problems using proportions. We're also going to solve problems using the percent equation. Percents that compare whole quantities represented by 100 and parts of the whole. Percent indicates a ratio, 1 with a base of 100. So percent means per 100. Before we do proportions or equations, I want to talk about a mental math strategy that works with multiples of 10%. These come in handy when you're trying to find 20% of a discounted item or 30% off, or maybe you wanted to calculate 20% tip at a restaurant. Well, 10% of a number just says we're moving that decimal one place to the left. So 10% of 40 is 4. What if I wanted to find 20% of 40? Well, 20% is just 10% times 2. So if 10% of 40 is 4, we'll take that 4 times 2, and that'll give us 8. Let's look at another. 30% is 3 times 10%. Well, 3 times the 10%, which was 4, will be 12. I hope you're starting to recognize a pattern here. So let's jump to what is 60% of 40. We already know that 10% is 4, so 6 times 4 will give us 24. Let's look at a second example. Let's find 10% of 120. Remember, 10% is telling us to move that decimal one place to the left. So 10% of 120 is 12. So now let's find 40%. Well, 40% is 4 times 10%. And if we know 10% is 12, 4 times the 12 will be equal to 48. Let's look at an additional problem. What is 70% of 120? Well, that's 7 times the 10%. If we know 10% is 12, then we have 7 times 12, which will then be 84. So this works with just multiples of 10, 10%, 20, 30, 40, 50, 60, so on. Now also, there are times when you can use some ballpark estimations. We can easily calculate 50% of any number. It's just 1/2. So if we think about that, we can use that sort of as a midway point or a guideline to see whether our actual percent will be higher or lower than that. So it helps to know that as a baseline. So percent proportions. If a percent is written as a fraction, a proportion can be used to solve a percent problem. And we're going to have something like A is to B as P is to 100. And we're talking about part to total. Some call it part to base or part to the whole. I generally call it part to the total. And you may have used this in former classes, the is of. 20% of the total is a part. So what percent of 50 total is 25? We can set up this proportion. Again, this time we're looking for percent, so that's where my unknown is. I can then create once I create the proportion, I can now do my cross products. So I can have 25 times 100, we'll multiply the extremes times the means, and that will give me 50p. You then go ahead and multiply, and again, multiplying by any kind of multiples of 10 or 100, easy, we're just going to multiply. And lastly, you will divide by 50. All right, so again, easy enough to calculate something like this, and you solve and find your value of P. Now this time again, we were looking for a percent, so always be careful when are you looking for a part, are you looking for a total, or are you looking for a percent? So again, as I'm looking at this, we see that this will divide out, and I'll get 50, so this is 50%. On to one more problem. So, well, actually, before we get to another problem, we're either going to be asked to find the percent, but that means my unknown is right here, or we could be asked to find the part. So if I have my A is to B is equal to a percent over 100, whatever that total is. If I'm looking for the part, then I'm looking for the A. If I'm looking for the total, I will give you the percent, and you'll be solving for this total or the base. So there are the three basic types of percent problems. Let's look at one more of this find the percent type of problem. What percent of 90 is 25? So we're going to substitute given values into the percent proportion. That proportion again is A is to B as whatever that percent is to 100, because percent is a ratio to 100. 100 is the base or the denominator. We substitute in the values because we know the total is 90 and the part is 25. Again, part to total. We'll now use the cross products property by multiplying the extremes, 27 times 100 and 90 times P. We'll go ahead and multiply this out. Again, these are easy calculations. Then we'll divide both sides by 90. And I could easily cross out some zeros here, and I then divide, and I'll see that this is going to be 30%. If I'm looking for a percent, I must include that symbol in my answer. What happens when I have the percents and I'm looking for the parts? Again, I can set up this proportion. 25% is 25 out of 100, part to total. What percent of is my total? Okay, so what percent? I'm looking for the part. I will again do cross products. 100x is equal to 16 times 25. You go ahead and you multiply and then divide by 100. Can't get much easier than that. We have 16 times 25, which will give us 400. And then we'll divide by 100. And x is equal to 4. Now, knowing a little something about percents and writing them as fractions and simplifying them, this could have been a mental math. I could have said, oh, 25% is equivalent to 1/4, and 1/4 of 16 equals 4. There are lots of ways to work these numbers in your head. It's all a matter of what you're comfortable with. Some of them must be written out and calculated step by step, and others go into some simple mental math problems. I'm not going to go into the equation method today. That'll be something for next class. And then we'll talk about applications. We'll be looking at finding discount or interest or commission. And then we'll get to something called percent of change. And we're just about done with this chapter. So we'll meet up in class today and discuss percents more. See you then.